Hi everyone. So the next topic for this week is called Ohm's Law. Ohm's Law. We're still talking about measuring electricity, and what Ohm's Law is a relationship, a mathematical relationship between the three electrical quantities that we've been talking about, which are voltage, current, and resistance. The Ohm's Law is basically broken down into two parts or two concepts. The first concept is that when voltage goes up, current goes up in proportion. And then the second part says when resistance goes up, current goes down in proportion. So it's basically talking about how voltage affects the current in a circuit and how resistance affects the current in a circuit. So just a reminder of what current is. Current is how fast the charges are moving around. So when the voltage goes up, voltage is the energy you give to the charges. It's going to make them go faster. So that's why when voltage goes up, the current goes up. And resistance is something that slows down charges. So when the resistance is higher, then the current goes down. But two words I've added here are in proportion. Okay, so like voltage goes up, that causes the current to go up. But how much does it cause the current to go up? Well, they go up together in proportion. And I want to try to explain what those two words mean, in proportion. So I'm back at my virtual circuit construction kit. I've got here set up a simple circuit. I know it's looking a bit more complicated now, but that's just because I've added the voltmeter and the ammeter that you may be familiar with from the last lesson. But really this circuit is it's only got one battery and it's got one light bulb. That's it. One battery, one light bulb. And what I'm going to do is I'm actually going to start with some smaller numbers. So you're actually able to click on the battery, and then a slider pops up at the bottom where you can adjust the voltage of the battery. So I'm actually going to bring it all the way down to 1 volt. And then you can do the same with the resistance of a light bulb or a resistor. So I've got a light bulb here. I'm going to click on it. When I click on the light bulb, I get a slider at the bottom where I can adjust the resistance of the light bulb. Right now it's at 10.0 ohms. I'm going to bring that all the way down to 1 as well, 1 ohm. Okay, so I'm going to start with simple numbers, 1 volt, 1 ohm. And according to the ammeter here, the charges are moving at a rate of 1 amp. Okay, so 1 volt battery supplied to a 1 ohm light bulb will create a current of 1 amp. So those are the simplest numbers that you can get. And now to show you what Ohm's law is talking about and what it means, those two words, in proportion. Well, so the current's at 1 amp. Now, what happens if I double this voltage? So what if I change this voltage from 1 volt to 2 volts? How do you think that's going to affect the speed of these blue dots? Well, Ohm's law says that the effect is going to be proportional. So if I double this voltage, I should actually double the speed of the blue dots. So let's see, I'm going to change this to 2 volts. And are the blue dots going twice as fast now that I've doubled the voltage? Well, according to the ammeter, it does. Okay, so because now it reads 2 amps, which was double from the answer we had before. And then I'll triple it now, so I'll put this up to 3 volts. And you'll see that the blue dots go even faster, and the ammeter's reading 3 amps. So that's what it means to be in proportion. When I double the voltage, I double the current. If I multiply the voltage by 10, then I'll actually multiply the current by 10. So let me put this up to 10 volts. Now they're going really fast, actually 10 times faster than when it was just at 1 volt. And the ammeter says 10 amps there. Okay, I'm going to bring it back down to 3. Okay, so I've got 3 volts and 1 ohm, and that's producing 3 amps. Now I'm going to show you what happens when I change the resistance. So I'm going to click on the light bulb. I can change the resistance of it. So that's how much they're slowing the blue dots down. Okay, so right now it's set to a resistance of 1 ohm. And that's causing a speed of 3 amps for the blue dots. So what happens if I double this resistance? Okay, if I make this twice as resistive, what's going to happen to the speed of the blue dots? Well, because the relationship is a proportional one, if I double the resistance, then the speed should get cut down in half. Okay, if I double the resistance, the speed or the current should be cut in half. So what's half of 3? Okay, half of 3 is 1.5. So let's see if that happens when I double the resistance. So I'll change this 1 ohm to 2 ohms, and now they all slow down. There's more resistance, so they slow down, and according to the ammeter, it indeed slowed down by half as much. Okay, I'm going to go back to 1 ohm. Okay, so 1 ohm and 3 volts, that's creating a current of 3 amps. Now I'm going to triple this resistance. So I'm going to change it from 1 ohm to 3 ohms to triple the amount of resistance I have. How will that affect the current or the speed of the blue dots? Well, if I triple the amount of resistance, the speed should actually be 1/3 as much. Okay, it'll be cut down to all the way to 1/3 as much. So this 3 amps should be cut down to 1/3 of that, which will just be 1 amp. So let's see that happen. I'll change this to 3 ohms. Okay, I tripled the resistance. That made C slow down to 1/3 of what the original speed was. And that's Ohm's law. All right, that's basically what Ohm's law is saying. Increase the voltage, that will increase the current in proportion. Increase the resistance, that will make the current get slower in proportion. And there's actually a formula to match this relationship. Well, first of all, here's a slide this is just a table showing what I just did on the virtual circuit lab. But here's the formula for Ohm's law. So the formula gives you a formula for current. Okay, so how fast the blue dots are going to move is going to equal to the amount of voltage divided by the amount of resistance. Current equals voltage divided by resistance. In symbols, I have that on the right side. I stands for current, delta V stands for voltage, R stands for resistance. But in these notes, which are provided to you in Google Classroom, I don't actually even use these symbols. I just write the full words out. All right, so I have 3 example problems here. So it's getting really mathy now. Okay, this is a math part of science class. So example 1, if a 10 ohm light bulb is using 3 volts, what is the current passing through the bulb? Okay, so to do this, I'm going to copy out the formula. So this is just the formula from the previous slide. We call this formula Ohm's law. And what this question is asking us to do is find out what is the current. Okay, so we have to find out the current, and according to this formula, the current is going to equal the voltage divided by the resistance. And I have these 2 numbers right in the question. The voltage is 3 volts, and I'm going to divide that by the resistance, which is 10 ohms. So I just replace those two, the voltage and the resistance, with the numbers they give me in the question, and I'm supposed to do 3 divided by 10. Okay, 3 divided by 10 is 0.3. And please do not forget to include the units of your answer. 0.3 what? What is current measured in? Current's measured in amps. So the final answer is 0.3 amps. I built a circuit for that. So you can see 3 volts being provided to a 10 ohm battery, and the ammeter shows 0.3 amps. Okay, next question. Question 2. If 0.4 amps are passing through a 20 ohm light bulb, what is the voltage across the light bulb? So now we have to find out how much voltage is provided. So it's a bit of a different question. There's the formula, same formula. We have to find out the voltage here. So the first thing I'm going to do is fill in the values that I know. I know 0.4 amps is the current, and I know 20 ohms is the resistance. So I fill in the values I know. So this is saying that my voltage divided by 20 has to equal to 0.4. I have to find out what the voltage is. So basically I have to figure out what number, when I divide it by 20, gives me an answer of 0.4. And the way to do that from math class is to actually just multiply these two numbers together. Okay, so multiplication is the inverse operation of division. Okay, so I'm doing something divided by 20 has to give me 0.4. To solve what that something is, I do the inverse of dividing by 20, which is multiplying by 20. So if I just multiply the 20 by the 0.4, I should get the answer. I do that in the calculator. That actually equals to 8. And then I can write the units in there as well. The units for voltage are volts. I have a bit of a sneakier way to do it. If you really don't like doing this math stuff, a sneakier way to do it is to use this program here. Okay, so the question says I want 0.4 amps when the light bulb is 20 ohms. How much voltage do I need? So with this circuit, I can click on the light bulb, set it to the number of ohms the question said. It said it was 20 ohms. And then I've got the ammeter here. It's reading 0.15. So the question wants the voltage, the question wants the current to be 0.4. The question wants the current to be 0.4. How much voltage do I need? Well, what I can do is I can click on the battery and just increase it until I get to the amps that I want. Okay, there. I've got 0.4 amps, which is what the question wants. And to get that, I had to get my battery to 8 volts to do that, which is the same answer we got with the math. So you can use the program to kind of play around until you get the numbers that the question asks for, or you can do the math. There is a third problem, which I'm out of time now for this video actually, which is when a 6-volt battery supplies a light bulb. Well, a light bulb is supplied with 6 volts. You get a current of 2 amps. What's the resistance of the bulb? So really quickly, here's the formula. I've got 20 seconds. I have to find out the resistance. I plug in the current of 2 amps and the voltage of 6. So 6 divided by something has to equal to 2. 6 divided by something has to equal to 2. Well, the answer is 3 ohms.